For the past 2 years, the entire AI conversation has been just completely obsessed with a single question, right? Like, which software model is the smartest?
Yeah, it's been like a spelling bee.
Exactly, a spelling bee. We've been hyper-focused on, benchmark scores and
hmm
parameter counts, but that era is effectively over.
hmm It really is.
The real battle happening today is about who owns the physical chips. It's about how governments are suddenly treating AI like the new oil, and why your company's cloud bill is skyrocketing out of absolutely nowhere.
Right. It's a total paradigm shift.
So welcome to the AI Pulse. Today's deep dive is unpacking this massive stack of intelligence for you. We're going to show how AI is transitioning from like a neat software tool into global critical infrastructure, and more importantly, what that transition means for your strategy, your budget, and your daily workflows.
Yeah, because this shift from a laboratory marvel to actual utility-grade infrastructure, it changes the fundamental economics of the technology.
Yeah.
We're looking at a landscape where the software capabilities have actually outpaced the physical world's ability to support them.
Right, the intelligence is there, but
But the power grid, the silicon supply chains, the data centers, they're buckling under the weight.
you're just buckling. Yeah. And I think that physical bottleneck is the perfect place to start. So let's look at what is happening with the hardware itself. Because you simply cannot understand the future of AI software without understanding the metal that's actually running it.
Exactly. You have to look at the metal.
And the big news from our sources today is OpenAI unveiling its first custom AI chip, which they developed in partnership with Broadcom. I mean, a company that is basically synonymous with software is diving headfirst into silicon design.
Yeah, and it speaks to the brutal reality of scaling artificial intelligence right now. Um, the traditional approach was always just to buy external compute.
Right, from the big players.
Exactly. You relied on third-party hardware from the established giants. But the problem is that every single time you, the user listening to this, ask an AI a question, it requires a measurable amount of compute to generate that answer.
And those costs add up fast.
Oh, incredibly fast. As we move from, millions of queries to billions of autonomous agent actions, those infrastructure costs threaten to just wipe out the margins of any software company that doesn't control its own silicon stack.
So they basically have to stop just buying compute and start engineering it.
That's exactly it. They have to engineer it.
And the focus of this new chip is also incredibly telling, I think. Like, they aren't trying to build the ultimate processor for birthing new massive models from scratch.
No. They're optimizing specifically for inference.
Right, the day-to-day execution of the models that are already in production, because when you're processing millions of user prompts every single hour, the engineering priorities shift, right? It moves away from just raw power and toward reducing latency, managing thermal output.
And cutting the energy cost per token.
Exactly.
Controlling that inference compute is becoming really the only way to make the business model sustainable.
Because you can optimize the silicon to handle your specific models.
Right. You tailor the architecture for the specific math your proprietary models run the most. But, and this is the crazy part, even if you design the most efficient processor on the market, you hit another physical wall.
Oh, right. The sources highlight this as the true hidden bottleneck in the AI economy right now.
Yeah. Memory bandwidth.
Yes. High bandwidth memory, or HBM. I was so struck by the focus on this in the research because the assumption for years was that the AI race was purely a GPU race. Like, if you had the graphics processing units, you were winning.
That was the narrative, yeah.
But modern architectures, especially, the new reasoning models that chew on complex problems for a while before answering, they have to move astronomical volumes of data in and out of the processor simultaneously.
Yeah, the processors are basically starving for data.
Wow, starving for data.
I mean, you can design a compute unit that's capable of billions of operations per second. But if the bus width, which is the physical pathway between the memory banks and the processor, if that's too narrow, the GPU just sits there.
It's just idling.
Exactly. It just idles, waiting for the data to arrive. It's the classic von Neumann bottleneck, but amplified to this microscopic, massive scale.
I like to use the analogy of a cocktail straw. Like, you can build a massive 1,000-horsepower engine, but if you're trying to feed it fuel through a tiny plastic cocktail stirrer,
The engine's power is totally irrelevant.
exactly, it's irrelevant. So HBM widens that straw into a massive pipeline. But based on the engineering specs we looked at, building that pipeline is incredibly complex. Like, they aren't just soldering memory chips next to the processor anymore.
No, no, the engineering is mind-blowing. They're actually stacking DRAM dies vertically, one on top of the other.
Like a skyscraper.
Yeah, like a microscopic skyscraper. And they punch these tiny holes through the silicon, they're called through silicon vias, just to connect them all. Then they place that entire stacked memory tower on an interposer directly adjacent to the GPU.
And the precision required for that must be insane.
It's staggering. It's highly prone to defects, which means the yields can be really low, and so the supply chain is incredibly constrained.
Which fundamentally elevates those memory suppliers. I mean, they're no longer just component vendors selling commodities. They are now strategic gatekeepers to the entire AI ecosystem.
Absolutely.
And because this specialized hardware is so difficult to manufacture and so expensive and so concentrated in just a few supply chains, the stakes move way beyond corporate profit margins.
Right. Which brings us to the geopolitical side of things.
Exactly. This hardware bottleneck is the exact catalyst driving this geopolitical scramble we're seeing in the sources. Because when a technology becomes this resource-intensive and this deeply integrated into the economy, it crosses a threshold.
It becomes a matter of national security.
Yes. Governments are suddenly recognizing that advanced AI is critical national infrastructure, like on par with the energy grid or telecommunications.
Yeah, or advanced semiconductor foundries.
And the sources show the U.S. government shifting from, like, a passive regulatory stance to active strategic integration. For instance, the sources note the Trump administration recently deployed Anthropic's Mythos platform across more than 100 U.S. companies and government agencies.
Right. And this isn't just about handing out basic chatbot subscriptions to federal employees.
No, not at all. The implication is that they are building isolated, highly secure environments for classified or sensitive federal data to interact with these frontier models.
Yeah, and federal officials are also engaging directly in the deployment timelines of the technology itself.
Right, stepping upstream into the development.
Exactly. The reports note that there have been requests for OpenAI to delay or stagger the release of information regarding new models. The government wants, security reviews, staged rollouts, a structured approach to how capabilities are introduced.
Because an unchecked release could have immediate implications for cybersecurity or defense readiness. But that naturally creates friction globally, doesn't it?
Oh, absolutely it does.
If the U.S. treats frontier AI as a closely guarded strategic asset and uses export controls to limit access to advanced models in specific regions, other nations are forced to react.
Yeah, they can't just sit there.
Right. So we're seeing parts of Asia who are facing these restrictions on American tech, aggressively funding and building their own local frontier-scale models just to ensure they have the underlying utility.
Because a core layer of your digital infrastructure cannot rely on a foreign provider, especially one who might just revoke your access based on a sudden shift in foreign policy.
That makes total sense.
And that realization is exactly what's driving the push for sovereign AI. Look at Europe, for example. There's an Italian startup named Damen that's gaining a lot of traction.
Oh, yeah, Damen.
Yeah. They're pursuing AI sovereignty through open source development. They're focusing on models built within the regulatory framework of the EU, trained on European linguistic nuances, and guaranteeing local data residency.
I do wonder about the long-term impact of that localized approach, though. Like, the early internet thrived because of global standardization, right?
Right.
Everyone used the same foundational protocols like TCP/IP, which created these massive network effects.
Right, the open internet.
Yeah, but if we enter a world where Asia has its AI ecosystem and Europe has its sovereign open source models and the US has its heavily guarded proprietary models, that fragmentation seems like it could severely fracture global digital workflows. Like, are we losing a universal baseline of intelligence?
It's a fair question, but the counterargument is that AI isn't simply a communication protocol like TCP/IP. It's a cognitive utility.
A cognitive utility. That's a good way to put it.
Yeah, and because of that, it inherently reflects the values, the laws, and the data privacy standards of its creators.
Yeah.
So for an international enterprise, a fragmented, multipolar AI landscape might actually be preferable.
Really? How so?
Well, think about a regional bank in Frankfurt or a healthcare provider in Tokyo. They legally cannot send sensitive customer data to a black box server in California.
Ah, right. GDPR and local data laws?
Exactly. So they will choose the local, sovereign, compliant model every single time, even if it performs slightly lower on some standardized logic benchmark than the leading American model.
Wow. So resilience and compliance end up trumping raw capability.
Every time.
The enterprise doesn't care if the model can write a brilliant sonnet. They care if the model is legally permissible to use and that it won't be abruptly taken offline by some trade dispute.
Exactly.
And that actually brings the geopolitical macroeconomics directly down to the daily reality of the corporate budget, because the sheer cost of this infrastructure is forcing a massive reality check inside companies.
Yeah, we're officially entering the FinOps era of AI.
FinOps, financial operations.
Right. For the past couple of years, the mandate from leadership was simply adopt AI. Employees were just encouraged to use generative tools for everything.
Just play with it, figure it out.
Exactly. But the hidden cost of that mandate is that organizations are using incredibly complex, compute-heavy reasoning models to perform trivial tasks.
Like drafting a 3-sentence meeting invite.
Yes, or summarizing a basic internal memo.
It's like using a Ferrari to drive to the end of your driveway to pick up the mail.
That is exactly what it's like. And when you scale that across a workforce of 10,000 employees, each making a dozen requests a day, you are burning an absurd amount of expensive compute.
And those inference costs we discussed earlier suddenly hit the corporate budget.
Hard. But you can't just revoke access, right? You can't tell employees to go back to a blank page. So the solution highlighted in the research is something called model routing.
Model routing. Let's break that down for the listener.
So organizations are starting to build architectural layers that evaluate the complexity of a prompt before it ever reaches a model. Think of it like an API gateway or an orchestration layer acting as a traffic controller.
Okay, a traffic controller.
Yeah. If the user asks for a simple text translation or a grammar check, the router silently forwards that request to a lightweight open-source model running locally. That costs fractions of a cent.
Oh, that's smart. But if the prompt requires deep reasoning, like, say, analyzing a messy spreadsheet of financial data and writing a Python script to visualize anomalies, the router recognizes that semantic complexity.
Right. And it sends it up to the premium frontier model.
And the user interface remains totally identical, right?
Exactly. The employee doesn't know, or even need to know, which model is actually generating the response.
They just get the answer.
Right. The organization maintains the productivity benefits, but they drastically drive down the cloud infrastructure spend. It's really all about maximizing the business value extracted from every single token consumed.
Optimizing the cost is only half the enterprise equation, though. The other half is what these models are actually doing when they are put to work. And there's a massive shift detailed in the OpenAI agent report from AI assisting work to AI executing work.
This is huge. We're moving past the era of the digital assistant and entering the era of the digital worker.
A digital worker.
Yeah, because the passive paradigm of AI required a human in the loop at all times. You prompted the chatbot, it generated text, and then the human had to copy that text, open your email client, paste it in, format it, and hit send.
Right. The AI provided the raw material, but I still had to do the labor of moving it through my software ecosystem.
Exactly. But agents introduce an active paradigm. They're granted agency to plan a sequence of actions, retain context over time, interact with external tools, and execute workflows autonomously.
Just based on a high-level objective.
Yes.
And Google's Gemini computer use agent is probably the most striking example of this in our current research stack, because for the entire history of computing, humans have had to adapt to the machine.
Right, we had to learn their language.
Yeah, we had to learn where the developers place the menus, how to structure our data for their forms, and how to navigate their graphical user interfaces. But the computer use agent fundamentally inverts that relationship. The AI adapts to our software.
It's incredible. It utilizes computer vision to parse the pixels on the screen.
It's actually looking at the screen.
Literally looking at it. It translates the graphical interface into a spatial grid. It recognizes text fields, drop-down menus, submission buttons, and once it maps the interface, it predicts the X and Y coordinates of the necessary elements and generates actual operating system level commands.
To move the cursor and click the mouse.
To move the cursor, click the mouse, and enter keystrokes.
That is wild. It's interacting with the software identically to a human user, which means you no longer need to spend months building a brittle, expensive API integration between like a modern CRM and a 30-year-old legacy database.
Exactly. You just give the agent an objective. You say, update the customer records in the old system based on the new contracts in the CRM, and the agent visually navigates both interfaces to execute the data entry.
The operational efficiency unlocked by that capability is just enormous. But, and this is a big, but it introduces massive risk.
Yeah.
If autonomous systems are going to be clicking through legacy software, altering databases, and executing core business processes, the era of shadow AI has to end immediately.
It has to end yesterday. You absolutely cannot have employees using unvetted, consumer-grade agents to interact with proprietary corporate systems.
And we see Samsung institutionalizing this exact concern in the reports. They are aggressively expanding deployments of enterprise-grade tools like OpenAI codecs and secure ChatGPT environments across their entire workforce.
Right. The goal is to pull the usage out of the shadows.
Yeah, they want the productivity, but it has to happen within a centralized, secure perimeter where the intellectual property is actually protected and the data isn't being used to train public models.
Because when an AI moves from answering trivia questions to executing workflows, you need rigorous standard operating procedures. The governance layer becomes more critical than the intelligence layer.
You need absolute auditability.
You do. If an automated agent makes a critical error in a financial transaction or, God forbid, a healthcare record update, the compliance department needs to know exactly how that decision was reached.
And Anthropic's Claude tag is designed to solve that exact problem, right?
Yes, tag is crucial here. In highly regulated industries, a probabilistic black box output is just a non-starter. You can't just tell an auditor, well, the neural network guessed this was the right answer.
Yeah, that won't hold up in court.
Not at all. So tag focuses on enterprise-grade traceability. It basically creates a deterministic wrapper around the model's actions.
So it tracks what the model is doing.
It rigorously logs the metadata of the interaction. It tracks the specific retrieval augmented generation citations the model used, the exact system prompts that were active at the time, the user identity, the session state. It provides a highly detailed provenance trail.
Wow. So the competitive landscape for enterprise AI is shifting rapidly. It's no longer about who has the most creative model, it's about who has the most governable model.
Because a brilliant neural network is absolutely useless to an enterprise if the legal department vetoes its deployment.
Right, but once you actually implement that secure, governed, routed system, you can fundamentally reinvent how your business operates. And the travel booking platform, Omio, illustrates the end state of this perfectly.
Yeah, the Omio example is fascinating.
Because they aren't just deploying AI in the back office to help their developers write code faster or to help HR sort resumes. They're using AI to entirely rebuild the customer experience.
They're turning the intelligence layer into the product itself.
Exactly, because the traditional travel booking interface forces the user to do all the hard work, filtering through pages of flight times, comparing train schedules across like 6 different tabs.
And trying to optimize the whole itinerary manually.
It's exhausting. But Omio's integration changes the interface from a database query tool into an agentic guide. The AI interprets the complex constraints of the user. Like, say I want a route that balances cost, travel time, and I have specific layover preferences.
Right. The AI orchestrates all those multiple API calls in the background. It evaluates the options and presents a synthesized, actionable itinerary directly to you.
It handles the friction of the legacy systems, presenting this seamless interface to the customer. It basically transforms a tedious data retrieval task into a collaborative advisory session.
The model completely abstracts away the complexity of the underlying software infrastructure.
And that is a phenomenal thread connecting everything we've explored today. I mean, we started at the microscopic level, looking at how the physical constraints of custom silicon and the narrow bus widths of memory chips are dictating the economics of computation.
Yeah, the physical hardware.
Right. And then we watched how those hardware bottlenecks turned AI infrastructure into a matter of national security, sparking this geopolitical race for sovereign capabilities and open source resilience.
And then we traced how the massive cost of that global infrastructure trickles right down to the enterprise cloud bill, which is forcing companies to implement FinOps routing, secure their data with strict governance tools, and eventually deploy vision-based agents to execute tasks.
We have clearly moved beyond the model, spelling bee is over, and the industrial revolution of artificial intelligence is actively rewiring the global economy.
It really is. And, if we pull all these threads together, particularly the reality of vision-based agents that can natively parse and operate any screen, it leaves us with a fascinating and honestly disruptive question about the future of software itself.
Ooh, okay. What is it?
Well, For 40 years, the graphical user interface,
Hmm.
the menus, the dashboards, the icons, that has been the bridge between human intent and machine execution.
Right, the GUI was how we translated what we wanted into something the computer could understand.
But if an agent can natively read the screen, understand your intent through natural language, and literally click the buttons on your behalf, do we actually need the visual interface anymore? Right. Will enterprise software eventually become entirely invisible to the human eye? We might be rapidly approaching a reality where you simply speak an objective, and the invisible automated machinery of the enterprise executes it flawlessly in the background, without you ever opening a dashboard.
That the software interface itself might be the next thing rendered completely obsolete?
Yeah.
That is an incredible concept to leave you with. If this deep dive sparked a new idea or shifted how you're viewing your own organization's technology strategy, please leave a review for the AI Pulse. Subscribe to the show and share this deep dive with your leadership team or a colleague who needs a reality check on where the infrastructure of intelligence is actually heading.
Yeah, the physical and geopolitical realities are moving way faster than the benchmarks. Keep evaluating your tech stack and questioning your assumptions.
Keep questioning, keep learning, and we will catch you on the next deep dive.